Okay, so here we go. Line of best fit. So this is a little bit of a different direction than we've been going. We have been talking about ways of arranging data, and this is kind of a way of arranging data. It's about scatter plots. This is what a scatter plot is, okay? If you take your data points and you plot them, okay, you get scatter plots. Now, you are not going to be creating scatter plots. You are just going to be looking at them and pulling some information off them. So, if I look at a scatter plot, I can understand something about correlations. What does it mean to correlate something? Or what does it mean to have a correlation? There's some kind of a relationship going on. There's some kind of a trend happening. So if I look at this right here, this is kind of following a line, isn't it? Those points are all fairly close to a line, you could say, right? Is that line going up or is it going down? It's going down. So what we would say here is there is a negative correlation because the data is going down. Okay? You should be able to look at something like that and say that's a pretty clear negative correlation because they're pretty tight to, you could almost visualize a line going through there, right? Now, if I jump over to the far right, I'm going to skip the one in the middle for right now, but the one on the far right, what trend do you notice with that one? It's going up, which we would say then has a positive correlation. Okay. You will also hear some definitions about words here. Your x coordinate is known as your independent variable. Your independent variable. Because I could say what happens when x equals 1, what happens when x equals 2. The y coordinate is called the dependent variable, and that is because your y value, you only know what it is once you've plugged in an x value. It's dependent on what x is. So x is your independent and y is your dependent. You may hear that. Now these two correlations right here, again, I'm ignoring the middle one right now intentionally. This one was a negative, this one was a positive. One of those is a tighter correlation than the other, though. Which one? Negative, because those dots, or those points, are closer to being on a line, aren't they? These ones are a little bit more spread out. When you get further into statistics, you start talking about, okay, let's give a value to that. Let's say if it's really tight to a line, we're going to give that an R value of 1. It's called an R value. It's your correlation value. Whereas this one, it's not quite as tight to a line, but I can tell that it's still going up. So maybe my R value is like 0.5. Okay? Those are kinds of things that you will actually learn how to calculate or how to find. You can use like graphing calculators and computer programs to calculate that and learn how that actually helps you interpret the data. In the middle, what have we got going on? We have chaos, don't we? The points are everywhere. There is no trend of going up or down, right? They're just kind of all over the place. So we say this one has no correlation. Okay, so a negative correlation pretty much follows a line with a negative slope, right? A positive correlation follows a line with a positive slope, and if it's just kind of crazy and there is no trend of going up or down, it's called no correlation. Okay, now these three graphs, these are the exact same three graphs down here, right? So line of best fit examples. Draw the line of best fit. The heck is a line of best fit? Well, if I had to imagine that these were all approximately following a line, where would that line be? Well, it would be somewhere in here. So I actually prefer, let me see if there's one over here.
The homework?
Yes, it's right there. Okay. Does anyone have a clear ruler I can borrow?
I do.
Can I use a clear ruler? Can I borrow yours? Okay. So I'm looking at a clear ruler because I think that makes it easier because I can kind of see through it. Now, remember when we did our graphing zombies? And if your point was even just slightly off, what happened? It affected a zombie way over there, didn't it? Okay? You other people from other classes probably have no idea what I'm talking about. But anyways, we killed zombies first semester. So it's going to change. This is just an estimate because the line that I see might be ever so slightly different than the line you see. Okay? Which is why when you get to statistics again, you will actually do this on a computer rather than just eyeballing it. But I'm going to eyeball a line, and I don't know if that's the line of best fit, but it's a pretty darn good line. Okay? You might put yours angling a little bit further down because I kind of am up above all these points, but you want a line that you think all of those points are kind of trying to be on. Does that make sense? So I would say that's my line of best fit. So? What if there's no correlation? There's no line I can draw, right? But the positive one, I should be able to draw one that kind of just goes through the middle of everything, right? I should be able to approximate. That looks like a decent line that all of those points are following. Does that make sense? Obviously, it's just an estimate, okay? So mine might be slightly different than yours. Now let's turn over to the back side. Okay, so it says draw the line of best fit, but guess what? There's already a line of best fit drawn. Okay, so that's exactly what we did on the other side. The second part says write an equation of the line in slope-intercept form. What is slope-intercept form? Y equals mx plus b. Okay, and it's going to give me steps here. So, draw the line of best fit showing the general trend of the line. We already did that, or it's already given to us. Then, I'm going to start off with graph 1 and work through it down here. You follow? Down here. Step 2, choose 2 points on that line. The points may not necessarily be a data point. Now, this is where things are going to change. With line of best fit, your equation might be a little different than mine. Because we're doing this by hand, depending on which 2 points you choose, you may get an answer that's different, but it should be pretty close. If we find out that the slope is 2 and you get a slope of like 1.8, we're doing fine. But if the slope is 2 and you're getting a slope of -4, there's an issue going on. Make sense? So, looking at 2 points. If I pick 2 points, well, to me it looks like 0, 0 I could say is on that line. Would you agree? So on part B, I'm going to write 0, 0 because that's a point that I think is on the line. Do you see that? What's another point that's on the line? Well, this data point looks like it's on the line. So I picked 0, 0. And what's that point? 7, 8. So those are the 2 points I'm going to say are on the line of best fit. Okay? Now you may pick the point 5, 6 and 7, 8. Okay, but try and find 2 points that are actually on the line as much as you can. Okay? What does part C say to do? Now I have my 2 points. Find the slope using those 2 points. How do I find the slope using those 2 points I have? y2 minus y1 over x2 minus x1. So that would be 8 minus 0 over 7 minus 0, which is 8/7. Okay, so. Use the slope and one of the points to substitute into y equals mx plus b. Now I think, yeah, okay. So one of the 2 points, which one do I want to use? 0, 0 or 7, 8? 0, 0. Say 0, 0. 0, 0 is usually easy to use if you can because zeros are easy to calculate with, right? So if I do y equals mx plus b from 0, 0, y is 0 there. What's the slope? I just found that. 8/7. What's x? 0 plus b. So that's my substituting in. Now part E says solve for b. So in other words, solve that equation I just found. So that's 0 equals, what is 8/7 times 0? Do I need to subtract 0 from both sides, or can I just jump to here? Are you okay with that? Okay. So I now have my slope and my y-intercept. So I have my line as soon as I put it into y equals m, which is 8/7, x, and do I have to write plus 0? No, 0 I don't need to write. That's the equation of the line. Sorry, you can't see it. That's the equation of the line drawn through the data in the graph on the left there. Does that kind of make sense? We've done this process before. The difference is, where are you getting the 2 points from? Last semester I gave you 2 points and said write the equation of the line that goes through those 2 points. Now I'm saying pick 2 points that are on that line and write the equation of it. Okay? Yes, ma'am. Good question. In statistics, it would be 2 totally different chapters. In here, we're just introducing you to this concept of having a best fit line, and this part is reviewing first semester stuff. So, does it flow? Not necessarily the way I like things usually to flow, but we're trying to connect some things and introduce you to some things that'll be developed further later. Okay? Yeah, that was my question when I looked at it too. Okay, so let's look at graph 2. Okay, let's pick 2 points. Are any of the data points actually on the line? It doesn't look like any of them are actually on the line, right? So let's try and pick 2 points that are actually on the line. I always try and look for an intercept, like a y-intercept or an x-intercept, because that point will always have a 0 in it, which will make my life easier. What is this point right here if I use the y-intercept? That's 0, 9. I'm going to use that as one of my 2 points. Okay. Do you see any other points that the line goes through exactly? That looks like a pretty reasonable point, doesn't it? Yeah. Right there? Yeah. That's crossing right at grid lines? What is that point right there? 5, 4. Let's use that as our other point. Is it 6? Oh, you're right, it is 6. Since the line is drawing, it has to be a point that's on the line. It might not be a data point. 0, 9 was not necessarily a data point, was it? But it is a point that's on the line. So you use the data points to draw in the line, and then you pick 2 points actually on the line that you've drawn to write the equation from. Okay? So let's use those 2 points, and why don't you go ahead and go through that process and write your equation. I'll give you a minute to do that. All right, so it looks like I have -5/6 as my slope. Is that what you got? Now, hopefully that makes sense because I have a slope that's going down, so that slope should be negative, right? Good answer. Okay, so now y equals mx plus b. I'm going to plug in -5/6 for m. What point do you want to use, 0, 9 or 6, 4 to plug in for y and x? 0, 9. So what do I plug in for y? 9. And 0 for x. Do you see why I usually try and pick a y-intercept if I can? Because it's going to make that fraction disappear every time. So now I solve this. 9 equals -5/6 times 0 is 0. So what does b equal? Oops, 9. That's kind of weird. It's like a reflection. Do you see that? Or a rotation. Rotation, I think. Okay, so I know what b is. I know what m is. So what's my final equation? Y equals -5/6 x plus 9. So? All right, for graph 3, I want you to pick 2 points and do the process. Okay? And once you do that, that'll be the end of our notes. Can you handle that? Good. Okay, so I'm going to go through this, and I may pick different points than you, but if I do, it's okay. Now, I think it looks pretty much like this point is on there, so I'm going to use the point 4, 4. Did anyone else use the point 4, 4? Okay, a couple of you. I'm really wanting 0, 0 to be on there, but I don't think it looks like 0, 0 is on there, but I also don't think it looks like any other point is really exactly on there. 2, 3, or 3, 2, 3, 3. 3, 3, that's pretty close. If I can use 3, 3, that's just a down 1 over 1 slope, or up 1 over 1. 2, 2, that's pretty close. Yeah, but think about this for a minute. If I use 2, 2, isn't that giving me a slope of 1, up 1 over 1? I can pick 0, 0 and have the same thing going on. And I like 0, 0 because it's zeros, right? So I could pick 2, 2. I'm going to pick 0, 0 because it's going to be easier to work with, even though I can tell that a line with a slope of 1 is going to become less and less close. Do you see this? It's going to end up getting further and further apart the farther you go down the line. But it's the best I can do right now without knowing exact points. So if I use those, I have 0 minus 4 over 0 minus 4. That's a slope of negative 4 over negative 4, or what? Yeah? Okay. Now y equals mx plus b. I'm going to plug in 0 for y, 1 for the slope, 0 for x. And when I solve that, I get 0 equals 0 plus b. And I get another situation where b equals 0. So what is my equation here? Y equals 1x, which is just x. That's what I would say is the line of best fit there. Okay. Now again, if you chose 2 different points than I did, you may get something like y equals like 7/8 x. Well, isn't 7/8 pretty close to 1 because 1 would be 8/8? Yeah? Okay. So you might get slightly different, but you should be pretty close to what I have. Okay? All right, so let me go ahead and pass out your homework. Let me make sure to explain it first, actually. For all of these, the first thing you're going to do is you're going to state whether it has a positive correlation, a negative correlation, or no correlation. Then you're going to use a ruler to draw in the best fit line, and you're going to pick 2 points to write the equation of your line. Okay? That's what you're doing for these. If there is no correlation, you don't write an equation. You don't draw in a line. You just write no correlation, because there is no best fit line. Okay? Understand? All right. Happy studying.